It is time for Lesson 9 of the Earth Atmosphere topic. Here is a starter quiz with a mixture of questions from a few different lessons. Pause the video and test your memory of previous lessons' work. Pause it now. Let's go through the answers. Petrol and diesel come from crude oil. Carbon monoxide is CO, capital C, capital O. Complete combustion makes carbon dioxide and water. Incomplete combustion makes carbon monoxide. It's a toxic gas. Complete combustion needs more oxygen. Incomplete combustion happens with less oxygen. Global dimming is caused by soot or particulates, or you could see carbon. Greenhouse gases trap heat in the atmosphere, causing the greenhouse effect. Greenhouse gases absorb long-wave radiation, particularly infrared. The total mass of carbon added to the atmosphere as a result of all our activities is our carbon footprint. And photosynthesis is a natural process that can remove CO2 from the atmosphere. You could say fossil fuel formation or limestone rock formation. Those processes take millions of years. Photosynthesis is a natural, fast process that can remove CO2 from the atmosphere. Today's driving question, similar to last lesson, why are petrol and diesel bad for our health? But today we're going to concentrate on two different atmospheric pollutants, nitrogen oxides and sulphur dioxides. So burning hydrocarbon fuels from crude oil, like petrol and diesel, produces a wide range of atmospheric pollutants. Bad news all round. So not only carbon monoxide and soot particulates and carbon dioxide, but there is even more than that. Now, an atmospheric pollutant is a chemical, often a gas, which causes environmental problems in the atmosphere. So we're going to learn about two further ones today. So the two atmospheric pollutants we're going to learn about today are nitrogen oxides and sulphur dioxides. Okay, how bad is the air pollution in Bristol? There is a website which tracks the amount of nitrogen dioxide in the atmosphere of Bristol. I'm going to try and show it to you now. Right, here we go. Now, if you look at the key over here, the red dot means above the UK legal limits. In other words, if there's a red dot, then the air has got too much nitrogen oxide in it, and it's actually illegal. There are laws saying that this needs to be reduced down to a less harmful level. So Bristol has a lot of red dots, a lot of places where there is a measuring station telling us that there is too much nitrogen dioxide in the air. Now let's see if we can find Mangotsfield. Where would Mangotsfield be? Let's see Staple Hill over there. Let's see if we can zoom in. And I think I can see the school there. There's Mangotsfield School. There is no measuring station near Mangotsfield School. There's one over in Downend, and there's quite a few in Staple Hill. And you can see even in Staple Hill, there are 5 measuring stations measuring an illegally high amount of nitrogen dioxide. Now, where does the nitrogen dioxide come from in the first place? Well, we learned last lesson about combustion, a reaction with oxygen to release energy from a fuel. Now, the oxygen is drawn from the air. So air goes into the engine, and the engine is hot enough that nitrogen from the air will burn as well as the fuel. So the engine is designed to burn hydrocarbon fuels, but it's so hot that the nitrogen in the air will burn as well, and it reacts with oxygen to make nitrogen oxide. So nitrogen dioxide and other nitrogen oxides happen when engines are hot enough to burn nitrogen from the air. Here's an equation to show that, but this is so far an unbalanced equation because there's 2 nitrogens on this side, only 1 on this side. So there needs to be a 2 in front of this chemical to show that 2 lots of NO2 will be made. But hang on a minute, that leaves an unbalanced amount of oxygen. So there will actually be 2 lots of oxygen, O2, reacting to make 2 lots of NO2. That is now a balanced equation. You'll learn more about balancing equations if you haven't done already in the chemical analysis and quantitative chemistry topic. For now, just be aware, please, that this shows that nitrogen gas from the air is reacting with oxygen gas, also from the air, to make nitrogen dioxide. And that happens because the engine is so hot that the nitrogen from the air will burn with oxygen as well as the fuel. Right, there are other oxides of nitrogen that can also be formed. There's a few different ones. This is nitrogen dioxide because there's 2 oxygens. Di means 2 oxygens for 1 nitrogen. But there are a range of other formulas that can be formed. And for that reason, you might sometimes see this symbol, NOx. And that represents a range of different formulas for different oxides of nitrogen. But they are all similar to NO2. Right, we'll pause for a moment. What is shown by this equation? Pause the video and think of a sentence in your mind. Pause it now. Here we go with the answer. This shows that nitrogen gas from the air in engines reacts with oxygen gas, which also comes from the air, to form nitrogen dioxide, which is also a gas, and it is an atmospheric pollutant. It causes environmental problems in the air. Now, one of those problems is it is a greenhouse gas. You may remember this chart from a few lessons ago, and nitrous oxides of nitrogen were one of the greenhouse gases shown. So nitrogen dioxide and NOx, they can form, they are greenhouse gases which trap heat in the atmosphere, causing global warming. So nitrogen dioxide and other oxides of nitrogen are greenhouse gases, causing a greenhouse effect, leading to global warming. But it causes another problem as well as that. When nitrogen oxide is given out by a car's exhaust, it goes up into the atmosphere and it can react with the water in rain clouds. Now, nitrogen oxides react with water to form nitric acid. When the rain falls, it contains that acid, and that's where acid rain comes from. So nitrogen oxides, as well as causing global warming, they also cause acid rain. Nitrogen oxides lead to nitric acid in the rain. Now, there's even more problems than that. Nitrogen oxides also cause breathing difficulties. They make asthma worse. They cause respiratory problems. Now, for this reason, London has introduced a congestion zone where cars, lorries, and vans are charged money to drive. Now, the aim of that is to reduce the number of vehicles driving around the city centre, to reduce the amount of petrol and diesel being burnt, partly to reduce the amount of carbon dioxide and carbon monoxide, but also to reduce the amount of nitrogen dioxide. Okay, so one reason for congestion zones is to reduce the amount of NOx in the air because it's a greenhouse gas and it causes acid rain and it causes breathing difficulties. Now, because Bristol has this problem with nitrogen dioxide, we are also in line to get a clean air zone, a congestion zone, where certain types of cars, lorries, other vehicles will be charged to go into the centre of Bristol. But there's a big debate on how much of the city should it cover. You might have your own opinions about that. But let's test our memory. Pause the video. What are the environmental problems caused by nitrogen oxides, NO2, and other versions given the formula NOx? Pause it now. Nitrogen oxides cause global warming because they are greenhouse gases. They cause acid rain because they react with water to form nitric acid, and they cause breathing difficulties. How are the nitrogen oxides formed in the first place? Pause the video, think of a sentence. They are formed when nitrogen from the air reacts with oxygen from the air, but remember this takes place inside engines, and they form nitrogen oxides. Here's an equation. For example, N2 plus 2 lots of O2 makes 2 lots of NO2. Okay, right. Now, are there any other problems? Well, we mentioned back at the start, there are 2 atmospheric pollutants we need to learn about today. The other one is sulphur dioxide. So when we burn petrol and diesel and hydrocarbon fuels, we also produce sulphur dioxide. Now, where does that come from? Well, the sulphur comes from sulphur impurities that are dissolved in the petrol and diesel. So when we find crude oil in the ground, it often has sulphur in it. And that sulphur is mixed in with the crude oil and it ends up mixed in with the petrol and diesel. When we burn sulphur, it joins together with oxygen from the air to make SO2, sulphur dioxide. Here's an equation. So sulphur is a solid which is dissolved in the petrol and diesel because it was there in the crude oil as an impurity. It reacts with oxygen from the air to make SO2, sulphur dioxide. Dioxide because there's 2 oxygens for every sulphur. Di means 2. Now, sulphur dioxide, here is a map of America showing their sulphur dioxide measurements, and the red colour indicates high levels of SO2. Now, here is another chart showing the pH of how acidic the air is in America, and again, the red shows lower pH, which means more acidic. So high levels of acid rain in the same places as the SO2 was being measured. What that means is that SO2 causes acid rain. Now here's the British version, and you can see that the amount of SO2 is concentrated around the biggest cities because it's made by cars burning petrol and diesel, lorries and vans. It's also produced by factories burning fuels as well. But you can see from the British map that the acid rain actually tends to fall in the places with the most rain. So it's not necessarily the places which are burning the fuels which are receiving the environmental problem. And similar to nitrogen dioxide, when sulfur dioxide is given out by cars and lorries and vans and power stations and factories, the sulfur dioxide can react with water in clouds. Now, sulfur dioxide reacts with water to form sulfuric acid. When the rain falls, it then contains sulfuric acid because SO2 reacts with water in clouds to make sulfuric acid. Now, we can try to reduce this problem. We can try to remove the sulfur from the petrol and diesel, from the fuels, before the fuels get burnt. That'll help. We could also help by switching away from fossil fuels to more renewable power sources. Now, sulfur dioxide is also a greenhouse gas. It would be counted in this other gases category. So, sulfur dioxide is a greenhouse gas. It causes the greenhouse effect, global warming, climate change, and just to top it all off, it is also a toxic gas. Now, we have learned about a lot of different pollutants. Here is a giant memory check. How much of this can you remember? I'll be impressed if you can remember it all. So pause the video and just think to yourself, can you remember the names of the chemicals and all the many problems that they cause? Pause it now. Okay, let's go through it. Nitrogen dioxide, global warming, acid rain, breathing difficulties, sulfur dioxide, those three, and it's toxic. Carbon dioxide, global warming, climate change, carbon monoxide, global warming, and it's toxic. Carbon subparticulates, global dimming, smog, and also breathing difficulties. So many problems being caused by the burning of petrol and diesel and other hydrocarbons in cars, lorries, vans, vehicles, factories, and power stations. Okay, there are 3 true statements and 1 false statement. Which one is false? Pause it now. Let's go through it. Right, carbon dioxide, carbon monoxide, and soot all contain carbon atoms. True. CO2, CO, SO2, and NOx all cause acid rain. False. It is SO2 and nitrogen oxides that cause acid rain. Remember, the X means there are different versions of this chemical. So, carbon dioxide, carbon monoxide, sulfur dioxide, and nitrogen oxides can all cause global warming. Carbon monoxide and sulfur dioxide are both toxic. Also, nitrogen oxides and soot cause breathing difficulties. Okay, there is a lot to remember with all of this, so here is another big memory quiz. Pause the video and think of a short answer. You don't have to write it down, but pause for long enough to think of an answer to each of these questions. Check your memory on today's work. Pause it now. Let's go through the answers. Nitrogen dioxide is NO2. It is formed when nitrogen from the air reacts with oxygen in engines. Nitrogen dioxide is a greenhouse gas, true. The name of the acid made when it reacts with water in clouds is nitric acid. Nitrogen dioxide makes nitric acid. Yes, true, it does cause breathing difficulties as well. Sulfur dioxide is SO2. It is formed when sulfur impurities in petrol and diesel react with oxygen. It is a greenhouse gas, that is true. The name of the acid formed is sulfuric acid. Sulfur dioxide reacts with water to form sulfuric acid. And sulfur dioxide is toxic to both humans and plants. True. It is time for the writing task. A lot to remember, but hopefully doing lots of quizzing and thinking about it will help you to get it into your writing. Please remember the Google Doc exercise book in Google Classroom. It is the first assignment that we are using for all of the lessons. You can open that first assignment and scroll through the Google Doc until you get to lesson 9. It's got the driving question. It's actually the last content lesson for this topic, and it's got the describe, explain, use, combine already in there with some sentence starters. So you are going to be describing atmospheric pollutants that don't contain carbon. So concentrate on nitrogen dioxide and sulfur dioxide. Explain the effects on the environment. Explain how they are formed. Try and include an equation. And consider to what extent we need these congestion zones, low emission zones. How can that help? So here are the sentence starters. Pause the video for long enough to get your written work done. This is the most important part of the learning, to prove that you've learned it by writing out in your own words, to be able to check your own understanding and to practice explaining science in writing. Pause it now for as long as you need to work your way through these instructions. Pause it now. Okay, I'm going to move this video on to the answers. Please do remember to check your work. If it's wrong, change it. If there's something you didn't think of, add it in. The two atmospheric pollutants that don't contain carbon are sulfur dioxide, SO2. It comes from burning sulfur impurities in fuels, and nitrogen oxides, NOx, or you could say nitrogen dioxide, NO2, which are formed when nitrogen in the air reacts with oxygen. They are both toxic gases. Well, sulfur dioxide is particularly toxic, and they both cause breathing difficulties. They both react with water in clouds to form acid. Sulfur dioxide forms sulfuric acid. Nitrogen dioxide forms nitric acid. They are both greenhouse gases which cause global warming and climate change. Explain the formation. Well, petrol and diesel fuels contain sulfur impurities dissolved in the fuel. When the fuel is burnt, the sulfur impurity reacts with oxygen to form SO2. Then it can rise into the atmosphere. It reacts with the water in clouds to form sulfuric acid. Then when the rain falls from the cloud, it contains sulfuric acid. What about the nitrogen oxides? Well, engines use oxygen from the air, but the air also contains nitrogen. When the engine is hot, nitrogen from the air reacts with oxygen to form a range of nitrogen oxides. We give the formula NOx to represent a range of oxides. Here's one example. N2 plus 2O2 makes 2 lots of NO2. So 2 lots of nitrogen dioxide are formed when nitrogen gas reacts with 2 lots of oxygen. The nitrogen oxides, including NO2, rise up into the atmosphere. They react with water in clouds to form nitric acid. When the rain falls from the clouds, it contains nitric acid. We call that acid rain. Okay, you might want to pause this and read it through. I have written about how the low emission zones, the congestion charges, are there to reduce the amount of traffic by reducing the number of particularly diesel cars, trucks, buses, and lorries. And not only are we trying to reduce the amount of nitrogen dioxide and sulfur dioxide, but also trying to reduce the amount of carbon dioxide, carbon monoxide, and soot particulates. There are so many problems caused by these fuels, they all need reducing. So we need less vehicles in our city centre, and that is what the congestion charge is for. That is why we call it a clean air zone, to try to remove these atmospheric pollutants from the air. One thing to be aware of, though, is that the congestion charges only really affect diesel vehicles. Petrol continues to be allowed. That's because diesel is more likely to undergo incomplete combustion and produce carbon monoxide and soot. So that's why they've concentrated on diesel first. So that these problems will continue because we will still have petrol cars in the city centres. Right, okay. Now, today I achieved describe, because I can describe the atmospheric pollutants. Today I achieved explain, because I can explain the effect on our health. Today I achieved use, because I can explain the formation of sulfur dioxide and nitrogen oxides and explain how they react to form acid rain. Today I achieved combine, because I can consider the effect of low emission zones. To what extent will it help to ban diesel vehicles if petrol is still allowed? That's an important consideration for us as a society as we move forward. Please also think about what this says about you as a science student. Can you use your understanding to explain a scenario? Can you combine together a wide range of ideas to explain an extended scenario? Whatever you've achieved today, please do feel proud of yourself for putting effort into your science lessons. It's really important to do that learning, to keep your home learning going, to get your notes written, to test your understanding, to check that you're getting it right, to practice your ability to explain science. It's a really, really important part of your learning. So a massive well done from me for getting that work done today, and also for the previous lessons that you have completed. Very well done, Year 9 and Year 10 Trilogy students. Thank you for your efforts, and a very big well done from me. Bye-bye.